Hi. Today we will tell you about a very interesting warship. About the destroyer type of Zumwalt. If you like the video, don't forget to like it and subscribe to our channel. Thanks. The destroyer's type of Zumwalt is a new type destroyers of the U.S. Navy with missile weapons, with an emphasis on attack shore and surface targets. This type is a scaled-down version of the DD-21 program ships that have been discontinued. The first Zumwalt-class destroyer, DDG-1000, was launched on 29 October 2013. The main weapons of the destroyers of this series are 80 Tomahawk cruise missiles and artillery systems, which determines the main task of the destroyers to support land forces by attacking coastal targets. The ship uses a promising system for managing all weapons via Raytheon's TSCEI. With the abandonment of the concept of local computer systems, the destroyer has low visibility means that reduce its EPR by 50 times. The program is named after Admiral and Chief of Naval Operations Elmo R. Zumwalt. The TSCEI system is an American ship-based multifunctional combat, information and control system of Raytheon designed for the Zumwalt-type destroyers. This system has an open architecture and is based on a ship-wide computer network. It is well adapted for integrating standard software and commercial hardware. How was this warship designed and built? Among the U.S. warships being developed, the DDG-1000 should precede the littoral combat ship and possibly follow the CG-X cruiser, competing with the CVN-21 anti-aircraft. The DDG-1000 program is the result of a significant reorganization of the DD-21 program, whose budget was cut by Congress by more than 50%. Initially, the Navy hoped to build 32 such destroyers. This number was later reduced to 24, and then to 7 due to the high cost of new experimental technologies to be incorporated into the destroyer. The U.S. House of Representatives remains skeptical of this program due to the ship's problems with missile defense systems, which will be discussed later, as well as lower stealth and much lower loading of cruise missiles than the Ohio submarines. The old converted Ohio-class submarines are capable of carrying 154 cruise missiles against 80 missiles from the Zumwalt, and the cost of converting the old submarine is more than twice as low. Therefore, money was initially allocated only for the construction of one DDG-1000 for technology demonstration. Initial funding for the destroyer was included in the National Defense Authorization Act of 2007. In 2007, $2.6 billion was allocated to finance and build two Zumwalt-class destroyers. On February 14, 2008, Bath Iron Works was selected to build the USS Zumwalt numbered DDG-1000, and Northrop Grumman Shipbuilding was selected to build DDG-1001 at a cost of $1.4 billion each. According to the Defense Industry Daily, the cost could increase to $3.2 billion for each ship, plus $4 billion for the life cycle of each ship. On July 22, 2008, it was decided to build only two such destroyers. A few weeks later, it was decided to build a third destroyer of this type. Once commissioned, the Zumwalt-class destroyers will be operated alongside the Arleigh Burke-class destroyers. On December 7, 2015, the first of the three destroyers, Zumwalt, estimated at $4.4 billion by this time, went to sea for sea trials. On May 20, 2016, documents were signed for the transfer of the DDG-1000 lead ship to the U.S. Navy. The cost of building all three destroyers is estimated at $12.73 billion. The full cost of the program, which includes, in addition to the cost of building ships, research and development costs, is estimated at about $22.5 billion. In November 2017, it became known that the U.S. is partially reducing funding for the project by refusing to create some systems for subsequent vessels in the series. In particular, they will abandon the general ship computing environment and the vertical launch system of Mk-57 missiles. The ship's displacement is approaching 15,000 tons, which makes Zumwalt the largest modern non-aircraft carrying warships in the world after the Soviet-Russian nuclear-powered missile cruisers of Project 1144, whose displacement reaches 26,000 tons. There is a bulb in the elongated bow of the ship. The destroyer provides for the basing of a helicopter and unmanned vehicles. Due to the high degree of automation, the ship's crew will be only 140 people. The principal difference between the Zumwalt and other vessels was the unified TSCEI BIOS basic input-output system of Raytheon. What is the energy heart of this warship? Zumwalt used the method of the Universal Power Plant Turbine Generator electric motor, known from the Ohio submarines. The engine rotates only electric generators and then all energy consumers, from the radar to the engines that turn the ship's propellers electric. Instead of a nuclear reactor, Zumwalt uses a diesel gas turbine engine. However, such a system sharply increases the cost of the propulsion system, reduces its efficiency and reliability, so in the Ohio submarines it was only used for low-speed movement in creeping mode to reduce acoustic noise on the propeller shaft reducers. Stealth technology for Zumwalt was the main concept of the project. Therefore, the same design solution was chosen. However, the designers did not take into account that such a system proved to be insufficiently reliable and powerful for driving at cruising speed, so Ohio switched at cruising speed to the traditional direct supply of force from the turbine to the propeller shaft reducers, bypassing 2 stages of energy conversion. Zumwalt's designers convinced us Navy customers that they had solved the reliability problems of this class of installation and that direct operation via reducers was not required. But in practice, when trying to use the Zumwalt at full speed, the power plant broke down in less than 1 month of operation and required towing for repairs of vessel without power supply. Some analysts point out that perhaps the choice of a single power plant was associated with an experimental gun based on a railgun, which required an extremely large amount of electrical energy. But this gun has not yet been tested and is not installed on the ship. A traditional gun is used. Zumwalt armed with cruise missiles and artillery land caliber. The main armament of the ship is 20 Mk-57 universal launchers with a total capacity of 80 missiles. The main missile is supposed to be a Tomahawk. Missiles are placed along the sides in PVLS vertical launch installations. According to the designers, this increases the survivability of the ship, since when a rocket explodes, it does not occur inside the ship, but on board, with the main energy of the explosion being thrown overboard. Critics note that on the other hand, anti-ship missiles will almost always hit the Zumwalt ammunition and the explosion will be amplified by partial detonation of the missiles. For the destroyer, prototypes of the most exotic art system technologies, including the railgun, were discussed. But we stopped at 155 artillery installations of an unconventional active-reactive scheme, which provides an increased range of up to 148 km (LRLAP). At this distance, the artillery is able to accurately hit the target only with guided projectiles, and the accuracy is required higher than that of cruise missiles, since the mass of the warhead is much smaller. To achieve a range of 148 km, it was necessary to extend the rocket part of the active jet projectile of the artillery system, and therefore it does not fit entirely in the cradle of the artillery bolt. Gun, Zumwalt for reloading should take every time the vertical position. But the main reason for criticism from the Pentagon is that the cost of one guided projectile for the gun reached $0.8–1.2 million, and taking into account depreciation and current repairs of the gun, the cost of a shot reached $2 million. The Zumwalt projectile became more expensive than the Tomahawk cruise missile, which has an order of magnitude greater range and power of the delivered ammunition. The command of the U.S. Navy also questioned the LRLAP program, and in the budgets of 2016 and 2017 did not include the purchase of shells for the artillery system, and all 3 planned destroyers of the Zumwalt series are available only 100 shells produced by the manufacturer for $120 million in 2009. In 2016, the U.S. Navy Command considered abandoning LRLAP guns or changing ammunition, as the current cost of projectiles is unacceptable. Stealth technology. Zumwalt. The ship is made with flat beveled surfaces to reflect radiation from enemy radars into the sky. The nose of the ship is beveled as a breakwater also into the sky, since the sharp edge of the ship's nose is a strong reflector of radio waves. Immediately, many American experts in shipbuilding said that the profile with a blockage of the sides tumble home makes the Zumwalt dangerous for the crew due to reduced stability, and with a strong side roll, the ship can turn over. Therefore, uninterrupted operation of the ship's power plant is critical for the dynamic stability of the ship due to movement, since if the engine fails, the stationary vessel can be unstable. In response to this criticism, the ship's designers created a smaller copy of the Zumwalt with an electric motor and demonstrated this model to us Navy customers, proving that the ship is stable. Sharp corners and especially details of superstructures are strongly damascene reflecting objects, so many elements of the superstructure, although they look metallic under the paint, are actually made of wood balsa. When constructing the superstructure, cork wood panels were also used, but according to the designers, not for stealth means, but for thermal insulation. To prevent reflection from small protrusions on surfaces, the vessel is painted with ferrite paint that has partial properties of a radio-absorbing material. Due to these means, the effective reflecting area of the ship is reduced by 50 times, which does not make it, of course, invisible, but for the radar, the ship looks, despite its large initial size, approximately like a small felucca made of metal. It should be noted that the traditional electron optical converter is formulated for traditional X-band radars. Several accidents occurred during the operation of the ship. On November 21, 2016, the DDG-1000 suffered a main power plant failure while passing through the Panama Canal from the Atlantic Ocean to the Pacific Ocean, en route to the port in San Diego. Seawater has penetrated 2 of the 4 bearings connecting the ship's advanced induction onboard engines to its drive shafts. Both drive shafts failed and the plane crashed into the canal walls, resulting in minor cosmetic damage. The ship was towed to the Vasco Núñez de Balboa, a former U.S. naval base in the suburbs of Panama, for repairs. After repairs, the ship continued on its way to the San Diego Naval Station. When the ship arrived in San Diego, a leak was discovered in the cooling system of the lubricant, but the cause of the leak could not be determined. In December 2017, DDG-1000 aborted testing and returned to the shipyards located in Maine. The reason for the incident was that a day after departure from the shipyard, the destroyer failed harmonics filters that protect sensitive electrical equipment from unwanted power fluctuations. As a result, the ship lost the ability to use a complex electrical network at high loads. Thank you for watching this video to the end. We recommend you to watch our video about the Sea Shadow warship. The technology of this ship became the basis for Zumwalt, and our video about the main battle tank of the U.S. Army M1A2 Abrams. Thank you for liking this video and subscribing to our channel. Bye.